In this video, we're going to discuss the relationship between profit, cost, and revenue. And so obviously the idea is that producers want to maximize profit. So we want to explore this relationship between revenue and cost. We know that profit is the difference between revenue and cost. So P of Q, or we sometimes say this is pi of Q, equals R of Q minus C of Q. Also keep in mind marginal cost. Marginal cost is the cost of each additional item. It's the same thing as the derivative of the cost function. And marginal revenue is the revenue generated by each additional item. And that is the derivative of the revenue function. So looking at this relationship graphically, whenever revenue is below cost, like in this section in here, the revenue, the R curve, is below cost. In this section, we're actually experiencing a loss because our cost is outpacing our revenue. In this section here, we would be experiencing profit because now revenue is greater than cost. So just a couple observations from this graph. If you look at Q equals 140, then in this space here, you have the greatest difference between revenue and cost. So in this instance, I would say max profit is when Q equals 140. Now the difference, the space between those two things, the space between those two marks here looks like 80 and 60. That represents our profit. So I would say the max profit is $20 or is 20, whatever units we're in. So it occurs when Q equals 40 and it is 20. So to find the max profit, we're looking for the greatest distance. One other important observation that I want you to notice is look at the slope of each of those curves at that point. They look very similar, and in fact, they are actually the same. Remember, the slope of the revenue curve is marginal revenue. The slope of the cost curve is marginal cost. So profit is actually maximized when marginal revenue equals marginal cost. And I should also add, and revenue is greater than cost. All right, so in this example, we're told C prime of 80 equals 140. And R prime of 80 equals 192. What that means is marginal cost of 80 is $140. Each additional item after 80 items would cost $140. Marginal revenue at 80 equals $192. So that means each additional item generates $192. So estimate the profit on the 81st item. Well, the marginal profit, or the profit produced by each additional item, would be 192 minus 140. It's $52. That means each additional item we're actually generating $52 of profit. So the 81st item would generate an additional $52 in profit. And the 82nd item would be double that, or would generate $104 in profit. Well, what would happen if R prime of 80 was less than C prime of 80? Meaning our revenue is actually less than our cost. In this case, we would lose money on additional items. Okay? If the profit, pi of Q, is maximized when Q equals 120, what do you know about these two items, C prime of 120 and R prime of 120? Well, as we previously discussed, this would be marginal cost and this would be marginal revenue. If marginal cost equals marginal revenue, then we have maximized profit. So what do we know? We know marginal cost would equal marginal revenue in this situation. When marginal revenue is greater than marginal cost, the company should increase production to add additional profit. The reason is their revenue is outpacing their cost. So in this case, we're given a function for marginal cost, meaning it's changing with time. Then we're given that marginal revenue, no matter what, is actually $30. So what we want to see is our marginal cost greater or less than the $30? If it's less than the $30, we should increase production. If it's greater than, then we should slow production down. So let's see about 25 items. Marginal cost of 25 items would equal 0.03 times 25 squared minus 1.4 times 25 plus 35. In this case, marginal cost of 25 items would equal $17.75. Notice that that is less than the marginal revenue, which was 30. So since cost is less than revenue, we should increase production. Let's see what happens at 75 items. So the marginal cost of 75 items would equal 0.03 times 75 squared minus 1.4 times 75 plus 34. Here we get marginal cost of 75 items equals 97.75. So here cost is greater than our revenue of 30. Marginal revenue is 30. So in this case, we should decrease production. In this last example, we're going to look at maximizing revenue, what we can do to generate the amount of money we bring in. So recall this value here, R of Q equals P times Q. That is revenue equals price times quantity. The price we sell something at times the quantity that we will be able to sell. Meaning, like, if your price was $10 and you sell 15 items, you'd sell $150 worth of stuff. So we have this demand equation that price for a product equals 45 minus 0.01 Q. And we want to write a function R of Q. Well, R of Q equals P times Q. And here's what P is. So R of Q equals our price, 45 minus 0.01 Q times Q. So you can see I've simply substituted this in place for P. Doing some distributing in this Q, R of Q equals 45Q minus 0.01 Q squared. So we want to find the quantity that maximizes the revenue. If you recall, we previously showed that maximum and mins typically correspond to where the derivative equals 0. So what we want to do is take the derivative of R of Q and set it equal to 0. So we want to find R prime of Q and set that equal to 0. R of Q would equal, or R prime of Q I should say, would equal 45 minus 0.02 Q using our derivative rules. So to maximize that, we want to set it equal to 0. 0 equals 45 minus 0.02 Q. And if we solve that, negative 45 equals negative 0.02 Q. Dividing over, we will get that Q equals 2,250 items. So that's how many items we're going to sell. But we want to determine what price is going to generate that number of items. Well, if you look up here, here's Q, which will allow us to determine price. Price equals 45 minus 0.01 Q, which in this case is 22.50. So price equals $22.50. To get revenue, we know revenue is price times quantity. Now we know price and we know quantity. Revenue will equal the price, $22.50, times the quantity, 2,250. Revenue will equal $50,625.